This may be a long series, okay? Because there's just so many good biohacks out there that I can't let you guys hang, leave you guys hanging with all this good info. I want to start off by talking about a hike I did about a year and a half ago. And this is actually me and my wife out on this hike, and it's this 16-mile hike in Washington State. And we're going up this mountain, and we're going to like this, it's called Blanca Lake. It's like this glacier lake. So there's literally like ice chunks in this lake. And so by this time, we made it all the way, the 8 miles up to this lake. And of course, me being me, I had to jump in, even though it's freezing cold. And I realized something, that I jumped in, and holy crap, that was painful. I mean, probably like one of the worst feelings ever. But when I got out of that cold water immersion, and we're talking like ice cold water immersion, I don't know if you ever felt this, but I just felt amazing the entire rest of the day. That cold water did something to me, and I don't know what it did. I didn't know the physiological benefits at that time, but wow, I felt energized, I felt active, I felt light, and it's hard to describe, and maybe you guys have experienced that yourselves. Have you ever taken a cold shower before and feel how awake and alert you are? Even though at the time in the shower, it's painful and not fun, but afterwards, and if you compare that to like a hot shower, you feel a little sluggish after the hot shower, a little tired. That's like, oh, take a hot shower at night because it's gonna prepare you to go to bed. But if you take a cold shower, you're like ready. It's like your morning coffee in the morning. And so we I think as human nature, we knew that cold water exposure or cold therapy in the short term does a lot of good for us, and it makes us feel really good. But when you don't know the actual benefits, it's hard to keep wanting to do that because, let's be honest, it's kind of painful. It's not very fun, especially the first thing in the morning. I'm at 4 in the morning taking an ice cold shower. I mean, it's not very fun. But so when we're talking about biohacks, again, just as a review, it's the art of hacking your biology or maximizing your biological potential. And my favorite definition, the art and science of becoming superhuman, just like this little kid here. It's exactly what we're going to be doing. And if we're talking about biohacking, if we're going to actually become superhuman and maximize our biological potential, we have to look at one structure only, and that's this. Again, this is the cellular structure called the mitochondria. It's our energy producers of our cells. And so again, your health is literally correlated with the health of your mitochondria. If you have bad functioning mitochondria, you're not going to be healthy because you're not going to be able to produce energy adequately. And so it's your energy powerhouse. And why is this important? Because half of the people now under the age of 40 have early onset mitochondrial dysfunction. Half of you. And people over 40, it's way more than half. I just don't have the stat, but you're talking 3/4. So this is becoming a problem. And so if we're going to biohack our mitochondria, what we really want to do is we want to allow our body to increase more energy production. And we got to do this by something called mitochondrial biogenesis, getting the old kind of like a dysfunctional mitochondria out of our cells and producing brand new ones to kind of renew our body. And so if you remember back from last month on part 1, the biohacking premise is really based on a concept called hormesis. And hormesis is where we're basically being exposed to a short bout of healthy stress to get massive physiological benefits. And these short bouts of healthy stress include things like exercise, cold exposure, heat exposure, ketosis, etc. There's a lot of them out there. But those short-term bouts of stress are absolutely beneficial. And exercise, most people can relate to exercise, but that's a stressor. It's a short-term stressor, but we all know that exercise is good for us. So we don't always want to be in this just like complete comfortable state. We got to get out and expose ourselves to these beneficial short-term exposures to stress. And the reason why, because hormesis increases our mitochondria. So doing this is going to increase the amount of our energy-producing battery chargers of our cells, and that's what we want to do here. And so just as a recap, for those of you who couldn't make it last month, we talked about part 1 in our biohacking series, we talked about heat exposure, and that's things like infrared exposure from like saunas, but it also includes like dry saunas as well. But remember that heat is a healthy stressor. So when we are exposed to that, we're radically increasing the amount of heat shock proteins in our body, but we're also increasing free radicals, and we call that reactive oxygen species, or ROS. So we're increasing these substances. And then once you do that, boom, you have this cascade reaction of increasing growth factors in your brain, especially that activate, brain stem cells, everything. Protein synthesis in your skeletal muscle, so it's going to help you with hypertrophy or increasing lean body mass. It's going to help with sweating, and so sweating is the best way we can detox ourselves. So by detoxifying ourselves, by putting ourselves through short-term heat exposure, that's fantastic at getting rid of heavy metals such as mercury, cadmium, all sorts of things. BDNF, brain-derived neurotrophic factor, the heat also causes that to increase, and that's what actually activates your brain stem cells to make more new connections, more new synapses, more new neurons, which is awesome. It assists in plaque removal, so it's going to basically completely prevent things like neurodegenerative disorders, Alzheimer's, Parkinson's, etc. And also it's going to increase blood flow to our muscles, to everything, which is why it increases exercise endurance. And it does all of this through mitochondrial biogenesis, making new mitochondria. That's the premise here. And so here, these are the ways that we can increase or how we can biohack our mitochondria. And we talked about heat, and so now we're going to be talking about cold thermogenesis, or short-term cold exposure. And a lot of my information comes from Rhonda Patrick, who is definitely the expert, especially in these the cold and the heat biohacks we can do for our body and what it has to do with our mitochondria. So a lot of this information is coming from her. And if we're talking about cold thermogenesis, we got to talk about, first of all, we got to define what that means. And basically what that means is that when our body is exposed to cold, our body then has to increase our metabolism to produce heat. And as we're producing heat, we're also burning fat as a byproduct. So that's really what cold thermogenesis is. It's increasing our metabolism when we're in cold exposure. So two types. The first one is shivering thermogenesis, and this is what occurs in your muscle tissue. And so when we become cold, we all are aware of this, we start to shiver, and that's because your muscles are starting to contract. And that's actually our metabolism ramping up. But since our metabolism is not 100% efficient, we release heat as a byproduct. So the shivering increases the heat of our body, which is why we shiver in response to cold. Now, you also have a type of thermogenesis called non-shivering thermogenesis. And this is cool because this actually occurs strictly in your fat tissue. So this is where you increase your metabolism in your fat tissue. You're breaking down fat stores to increase the heat of your body in a response to cold that way. And believe it or not, that's what we're going to be talking about today, how we can increase the metabolism of our fat tissue. And so we got to talk about 5 concepts tonight that has, these are basically the main benefits of cold exposure. And we're first going to be looking at brown adipose tissue. Adipose means fat, so our brown fat in our body. Now, in general, as people, age or they're looking for fitness goals, most people are concerned with losing fat. But what they're really talking about is they want to lose that white fat, which is our harmful fat around our belly, around our organs, around our upper thighs and our hips. That's the bad fat that most people are referring to when they want to lose fat. But we also have this brown adipose tissue, this brown fat that is actually this super healthy fat. And instead of, again, it's the heat generating, it's the calorie burning good fat, and this is actually the fat that decreases naturally with age. But that's if you're not doing these biohacks that we're going to be talking about. But in general, this brown adipose tissue decreases as you age. And this, instead of white adipose tissue, that harmful fat that actually works to store fat around the body, brown adipose tissue, your brown fat actually burns your energy instead of storing it. So you actually want a very high concentration of this kind of stuff. And you're going to find brown adipose tissue in things like your neck. It surrounds your blood vessels to warm your blood. It also, too, is kind of mixed and matched with your white fat in your fat stores. So it's really everywhere. And what's interesting is you probably have noticed that a newborn baby does not shiver because they cannot do shivering thermogenesis. They don't have that potential. So basically, they're reliant strictly on non-shivering thermogenesis, increasing that metabolism in our fat tissue to increase the heat of our body. And infants actually have the highest concentration of brown adipose tissue. Now, That browning effect, the browning effect we're talking about is because there's way more mitochondria present in that fat tissue. And that gives it that brown color, and that's why it's so healthy, because it's so mitochondrially dense. And so the people with the most brown adipose tissue, since newborns have it, it's the people who are younger, who are slender, who also have normal blood sugar, basically people who eat a good diet, void of refined carbohydrates. People who are not on medications have higher amounts of brown adipose tissue. In fact, many of the blood pressure drugs alone are correlated with less amounts of brown adipose tissue. And also too, people with the highest concentrations of melatonin in their body have the most brown adipose tissue. Now, melatonin is released in our brain to prepare our bodies for sleep. So basically what that is saying is that people who are sleeping normally and getting that deep REM state of sleep have the most brown adipose tissue, because you can't be healthy and not sleep well. So it's really all these factors, and I mean, it's pretty obvious. So, we gotta be slender, eat a good diet, not be on medications, and sleep well. I mean, it's really simple there. But again, this is a picture comparing white adipose tissue to the brown adipose tissue. And so you're gonna see the brown, obviously it looks brown, but it's because it has so many mitochondria in there. And that's what we're gonna talk about, ways to increase that. And so here, this is another view of our mitochondria, just kind of a different view. But what I really want you to show you is that it's our battery chargers. So inside that mitochondria, in the inner membrane, you're gonna see this negative charge. And outside of that inner membrane, you're gonna have a positive charge. Just like a battery, you have a positive side and a negative side, because it gives you potential to produce energy. Basically that electrochemical gradient. Now, what happens is that when we're exposed to cold, if we take a cold shower, if we jump in a ice cold glacier lake, what we're going to basically be doing is we're going to be increasing the expression of this protein called uncoupling protein 1. And this basically destroys that entire electrochemical gradient in our mitochondria. So instead of having those positive sides and negative sides in our mitochondria, this uncoupling protein destroys that. So then, since we still need to produce energy and to create heat, your body, your mitochondria, basically have to work overtime and massively increase and try to reestablish this gradient by themselves, getting a positive charge on one side, a negative charge on the other, to produce more energy. So basically in the process, it's breaking down a ton of our stored white fat, our bad fat, in the process to generate heat. And so what it also does is it also allows our body, it stimulates our body to make even more and more mitochondria, especially in our brown adipose tissue. So basically what you're doing here is we're having a conversion of our harmful white adipose tissue to that healthy brown adipose tissue that increases our metabolism. And this is what's going on, because with all of these studies here, this is basically all these studies showing the benefits of cold exposure on brown adipose tissue. These studies show massive implications to weight and fat loss. And the reason is because if you have more brown adipose tissue, you're gonna have a higher metabolic rate because you have more mitochondria there. And the mitochondria are what produce energy. And it's also too, people with the most body fat percentages have less brown adipose tissue because they have way more concentrations of that white harmful adipose tissue of what's going on. And so when you enhance the conversion of white adipose tissue to that healthy brown fat from upregulating that uncoupling protein, it basically showing a lot of promise in the treatment of obesity, because you don't see many people who go and do regular cold exposure who are obese. It just doesn't happen. And so repeating this intermittent cold exposure, say you're doing a cold shower once a day, this has actually been shown to increase your brown adipose tissue by 37%. And this is short term. This isn't something like go in a cold bath for an hour. This is just short, intermittent term. And also too, the more and more brown adipose tissue that we're converting, we're also leading to a lot higher metabolism. In fact, these studies show a 93 to a 350% increase in your metabolic rate from short-term cold exposure, which is crazy. That is insane. But again, it's because, when you're exposed to this amount of cold temperatures, your body, it almost wants to go into hypothermia. But instead of, to avoid that reaction, your body is ramping up its metabolism because heat is a byproduct. So it has to ramp that up so much, so you're basically destroying all your white adipose tissue in the process. And that's why people who basically are very cold adapted, are very healthy and have a ton of brown adipose tissue compared to their white. And so besides brown adipose tissue, we also have to talk about norepinephrine. And norepinephrine is a stress hormone. And so, yes, cold exposure increases the stress hormone. But again, we're talking about short-term stressors here, hormesis, short bouts of stress. We're not talking about chronic stress, or a chronic increase in norepinephrine. So when norepinephrine is increased, basically when we're exposed to cold, norepinephrine gets released in our bloodstream and our brain. And in our brain, it has a couple effects. It helps with mood, memory, concentration, focus, but also too, in your rest of your body, it's a pain reliever. It's an anti-inflammatory. And with all these basically properties on mood enhancement, when you look at depressed people, almost every single one has chronically low levels of norepinephrine. And so this shows that intermittent cold exposure can be a great treatment because of the increases in norepinephrine. And norepinephrine also facilitates the increase in brown adipose tissue as well, increasing your metabolism. But it also works to vasoconstrict your peripheral arteries. Because again, if I jump in a cold bath, all the arteries outside of my body, they want to constrict because you're basically reducing the amount of surface area where blood can lose heat to the environment. And so that constriction is very important. What happens is that when we're actively being exposed to this cold exposure, we're causing a lot of constriction, in our arteries, veins, and we have these little smooth muscles around our arteries and veins. And so by allowing those muscles to be working more, contracting and everything, our blood vessels are going to be a lot stronger. Our veins are going to be stronger. Our circulatory system in general is going to be a lot more fit and strong by being intermittently exposed to cold exposure. And then it also acts as a signaling molecule. So norepinephrine also increases mitochondrial biogenesis as well. So you're having all these different signals telling your body to increase more and more mitochondria so we can produce more and more energy and be way more efficient. And so in general, the more mitochondria you have, the more heat you're producing and the more you're able to withstand the cold. And so that's the general premise there. So that's why if all you guys aren't used to this and you go and jump in cold water, you're going to freeze your butts off immediately because you're not used to this. But your body starts to adapt. Pretty soon you're able to put that shower on total cold for 10 seconds. And then in a couple of weeks, you may go to 15 to 20 seconds. So your body does adapt to this because because that whole process is basically increasing that brown fat tissue in your body. And the more brown fat tissue, the more you're able to withstand that cold exposure. And again, you're going to be able to double norepinephrine by just 40-degree water for 20 seconds. So that's almost how cold a shower can get, but also a 57-degree water for a few minutes. So that's literally just, the last couple minutes of your shower, just put it on cold and boom, you're going to be getting these benefits and you're going to be doubling the amounts of norepinephrine in your body to help with all of this. And so cold shock proteins, remember that heat produces heat shock proteins. Well, cold also does something like that and it produces cold shock proteins in our body. And the cold shock proteins are cool because, to backtrack a little bit, when you're looking at the physiological benefits of cold exposure, a lot of those benefits are done by studying hibernating animals. And animals that hibernate, bears, squirrels, etc., they basically have a major metabolic shift to conserve as much energy as possible before winter. That's the premise. So they are, look at the picture on the right, they are exposed to massive amounts of cold. So since your body wants to conserve energy, it basically shuts down almost all of its genes, with exception with the genes that have to do with, basically fat burning to generate heat to withstand that hibernation period, and also too, to increase the amount of cold shock proteins in our body. So all our genes get down regulated except the ones that have to do with these two processes. And what's cool is that you have these cold shock proteins in our brain, in our heart, in our liver, skeletal muscle. And when we're exposed to cold, this sounds weird, but it actually destroys your brain connections. It actually degrades your synapses in your brain, in your nerve cells. But as it destroys it, remember, the cold shock proteins that are increased in response to the cold actually counteract that degradation process and completely regenerates all of those brain cells again. So if you're looking for a way to renew your body, renew your brain, this cold exposure is the answer. And that's why you feel so dang good after a cold shower or after jumping in a cold lake. Not during that period, but after. It feels great. And it's because you're adding all of this stuff. So it's a completely legitimate way for recycling, regenerating, and giving your body a massive neuroprotective effect. Because again, you're regenerating all the synapses in your brain. And so they did a study, and they took these animals who were basically genetically engineered to get neurodegenerative disorders like Alzheimer's. And basically they took one group here, and they took the other group who were still genetically modified to get these Alzheimer's diseases. However, with this group, they allowed them to have intermittent cold exposure. And what they found out is that they got Alzheimer's, they got these neurodegenerative disorders a lot later than the other group. And it's because of that cold exposure, increasing those cold shock proteins and basically preserving those synapses, those connections between your brain. And so that shows a massive thing. And so in general, when you're talking about the aging process, as we age, we lose synapses. But if we know that these cold shock proteins increase the amount of synapses and protect our synapses, that shows a big promise to the aging process as well with cold shock therapy. And so now we're going to talk about inflammation. And, obviously in this office, we're always talking inflammation, how it's beneficial, how it's good, how it's part of the healing process. And it's true. It is. Inflammation is great. It basically eliminates the initial cause of cellular injury, clears out dead cells, debris, initiates tissue repair. That's all true. But the problem is that systemic inflammation is real and is a huge issue, because this basically means that you're having this inflammatory response in the absence of a biological threat, in the absence of a reason for that inflammation to occur. And so when we have this unnecessary inflammation in our body, that's called systemic inflammation, and this is actually the key driver in the aging process. And so what you're going to see is when you look at the studies done on these centenarians, these people who are over 100 years old, but they also did studies on semi-supercentenarians over 105, and also supercentenarians, people who reach over 110 years old. What they found out is that the only biomarker predicting survival and their cognitive ability is low inflammation. Because you don't want that inflammation to be happening for no reason. Obviously, you might have some local inflammation if you have any tissue injury, but having systemically going on in the body, that's not good. And if you have low inflammation, obviously that's the only biomarker that's in common with all of these centenarians reaching this, long of an age. And so, cold stress literally reduces these inflammatory substances, these markers, these cytokines in our body. And a couple of these, basically really damaging inflammatory cytokines are tumor necrosis factor, which is basically implicated in increase in almost every single disease known to man and woman. And also too, macrophage inflammatory protein. And so this is a type of inflammatory marker that is completely linked to rheumatoid arthritis. So you're decreasing all these inflammatory markers with cold exposure, basically preventing a lot of this stuff going on. And also too, this is just a study done on people with rheumatoid arthritis, and cold exposure not just reduces the amount of pain in their joints, in their extremities, but also too, it's decreasing the amount of inflammation going on, which is basically going to give them a whole better quality of life going forward. And in addition, this is cool too, because this study showed that cold exposure also inhibits an enzyme called collagenase. Now, I preach about collagen all the time with bone broth, with Great Lakes gelatin, because collagen is the glue to your joints. It helps with healthy joint formation, cartilage formation, joints, ligaments, tendons. So, and also too, the elasticity in your skin, keeping your skin looking fresh. Collagen is vital, and as we age, we don't produce as much. But this actually inhibits the enzyme that breaks down collagen. So that's good. So cold exposure does not allow collagenase to work as well, which is the enzyme that breaks down collagen, leaving us more collagen for our body to reap the benefits with that. So that's another great one to do. And then finally on this list, we're going to look at immune function, because your immune system's huge. And so again, your immune system has a huge role in aging as well. And you're going to see aging as a pretty, this is going to be a trending topic going on, because in general, you want a good arsenal of immune cells. of healthy immune cells. The problem is something called immunosenescence. It's kind of a tricky word to say, but this is where you have an abundance of immune cells, but they're not functional. And so that's obviously not going to be good because generally you want your immune cells in your body to be quiet and inactive unless there's actually a reason for those immune cells to be loud. So you kind of just want it like your other cells. You want them just there for only when you need it, kind of like inflammation. You only want that inflammation to happen when you need it. But what's going on is that when you look at these people who are reaching 100 years old, 105, 110, these guys have a much healthier biological stock of immune cells, of functional immune cells. And why? Because of cold therapy. And when you're looking at these studies here, this shows that cold increases these immune cells. And specifically, you're talking white blood cells, lymphocytes, cytotoxic T lymphocytes, which are actually severely toxic to cancer cells, natural killer T cells. And so, I don't know if you've seen, in the winter time, especially in like Northern Europe, you have a lot of winter swimmers. And so that's like a big known thing. And they've always had this popular antidote kind of saying that we never get sick. They hardly ever get any type of symptom of a flu, cold, nothing. They are never sick, but they're literally swimming in ice cold water on a daily basis. And so this is why, because when you're putting yourselves through this intermittent cold exposure, you're increasing the amount of immune cells, especially ones against cancer and everything, which is why these guys don't get sick. So now these guys have complete research to back up that they never get sick, which is awesome. And so, I always like to give out bonus, benefits. So we're gonna give a bonus benefit and talk about antioxidants. And what's cool is that cold exposure, when you're under the influence of cold exposure, we're increasing our fat metabolism. But anytime you increase your metabolism, as a consequence, we're also generating free radicals. But remember, those free radicals in the right amount are good. We want those free radicals. In fact, that's why heat exposure is so good, because those free radicals actually stimulate a lot of the changes that occur that we talked about in part 1. But these free radicals, so cold exposure increases the free radicals, but if we already have elevated free radicals to begin with, we do want some antioxidants to basically counteract those, so we don't have advanced aging, we don't have premature aging. And so what happens is that this cold exposure actually activates something called genetic antioxidant systems. And specifically, it increases the expression of these two enzymes called glutathione reductase and superoxide dismutase. So it increases the expression of these, and this is basically what kills out all the bad cellular debris in your mitochondria as a consequence of the wrapped up metabolism. It just basically cleans our bodies out. It's kind of like a autophagy, regenerating our bodies, clearing out dead, recycling new cells, and just regenerating ourselves. And so cold therapy literally increases these antioxidants, but it's these natural antioxidants our body makes, which is exponentially more stronger than any type we can take in a supplement form. It doesn't even compare. And what's cool too is that you actually can take too many antioxidants, especially in supplement form, because remember, these free radicals in the right amounts are vital, but you don't want them chronically elevated. But this increases our body's natural production of antioxidants. So we know we're giving our body the exact right amount to just clear out the excessive free radicals, but not all of them. And so that's crucial. Some people can actually take way too many antioxidants, and you're going to be actually getting more unhealthy as a result. Now, you can't really talk anything about cold therapy without discussing this guy here. And if you ever heard of Wim Hof, they also call him the Iceman. This guy, all I can say is he's crazy. So, this guy has exposed himself to cold on a daily basis for decades. And when you look at these pictures on the bottom, he does this daily on ice right there. And so a couple of crazy, feats he's done in his life is he reached the top of Mount Kilimanjaro in just shorts and sandals, no shirt, in 2 days, which is literally unheard of. He made it to the peak in 2 days wearing nothing but shorts. And they were like board shorts, super thin, okay, with sandals. And this guy's crazy. He also completed a full marathon, 26.2 miles, just above the Arctic Circle in Finland in -4 degrees Fahrenheit in nothing but shorts. A full marathon in -4 degrees. And he's doing it in really, really good times too, might I add. But this guy owns 21 Guinness Book of World Records, and I think the most impressive one is that he's stood fully immersed in ice for literally 2 hours. Fully immersed in ice 2 hours. And this is fully immersed in ice for 2 hours without his core temperature going down at all. So why? Because he has a crazy amount of that brown adipose tissue. And it's not because he's a superhuman guy or anything, it's because he's been doing this biohacking type of stuff for decades. So he's been actually training his body to do that. So he has this excellent metabolism. Now, Wim Hof actually has something called the Wim Hof Method, where he combines, this cold exposure with his specific breathing techniques, which is really cool. It's a little bit too complex to get into right now, but what's interesting is, so this guy, Wim Hof, he's claiming all this stuff, how he can, increase brown adipose tissue. And before there was a lot of information on all these benefits of cold exposure, this guy named Scott Carney, who was an investigative journalist, he basically had one agenda and one agenda only. He was basically gonna show up to one of Wim Hof's camps and basically just try to completely disprove all of his methods, so he can basically, write that in his next journal article, saying, oh, this guy's full of crap, sorry guys, this guy's weird. Because I mean, look at him, he meditates in ice, okay? It's a different guy. But basically what happened is Scott Carney, he went to one of Wim Hof's courses, and oh my gosh, just by training this, he too, eventually after completing the course, he hiked Mount Kilimanjaro in just his shorts. So this guy got the exact same benefits, and he's like, oh my gosh, this stuff is actually legitimate. And so he actually wrote a book about that. And it's called What Doesn't Kill Us. And so he just was like, all right, well, I got to come clean now. My whole goal was to slander this guy, but this guy actually turns out to be legit, and the scientific evidence proves that. And so I love this quote too. The more mitochondria you have in your fat, the more fat you're burning, the more heat you can make, the longer you can stay in the cold. Which is why this Wim Hof guy, I mean, wow. I actually want to go and try out one of his courses. It'd be pretty fascinating. But how do we implement this? How can we take this home right now? And I think the easiest way is a cold shower. And it doesn't have to be cold the entire time. Start off with a hot shower, but just that last 5 seconds, go to cold. Because again, it doesn't take that long of cold exposure to reap a lot of these benefits going on. Now, alternatively, you can jump in the ocean, you can jump in a non-heated pool, so you could do other things like that. I just think the shower is easier because, hopefully we take showers daily, so it's a good thing, okay? But also too, when you're doing this, you don't want to just do it any time of the day, because like we talked about last month, you want to avoid any type of cold exposure an hour after strength training. And here's the reason why. It's because an hour after strength training, you're going through a process called exercise-induced inflammation. This is where our body's basically repairing our damaged muscle cells from the workout. The heat shock proteins and the inflammation that strength training causes actually allows us to build more muscle mass, allows our body to naturally release anabolic hormones, these build-up hormones, to increase mass. And so if we expose ourselves in cold exposure within that hour period, we're going to completely negate all those benefits, which is why studies actually show that. They showed men, they took them in 2 groups, they were performing leg presses and squats, and they did this, I think it was like a 3 or 6 month training regimen, but one group got immediate cold exposure right after each training session. The other group did not. The group that did got it right after. They had 1/3 less muscle mass in their quads, and they also had lower muscular strength, smaller increases in their type 2 muscle fibers, which are your explosive muscle fibers. So they basically lost muscle mass, and as a result to going into cold therapy right after, because that cold therapy is negating that exercise-induced inflammation, that really helpful process. So that's why heat therapy, sauna, actually stimulates that exercise-induced inflammatory response. So a sauna would be completely appropriate right after strength training. But again, an hour after that, they actually did studies and they showed that you're getting massive benefits with the cold exposure. So you just want to avoid it within that hour after the workout, because that's when you actually can lose muscle mass instead of gain muscle mass, which is why most people want to work out in general, is to increase lean muscle mass. And so let's summarize it all. Cold exposure is going to increase not only your cold shock proteins, norepinephrine, but also too your reactive oxygen species, those free radicals, which in turn is going to increase the expression of brown adipose tissue, that healthy brown fat. It's going to increase fat burning. It's a massive anti-inflammatory. Immune function. It's going to increase those powerful natural antioxidant releases in your body. And also too, it's anti-aging because of the inflammation, the immune cells, everything. And again, all of this has to do with mitochondrial biogenesis, specifically in our brown adipose tissue. And so here's a list of the things we're going to be talking about in this series. And next month, part 3, we're going to be going over cyclical ketosis and cyclical something called mTOR activation. And I know I've talked about ketosis a lot, but it's just kind of like it's a fairly new science, and you're always learning more and more and more, so I always want to share everything I know with you guys so you guys can basically implement this stuff the safest and most effective way possible. And that's it, guys, so thank you very much. Appreciate it. It's very small, but we got a list of 11 references. Any questions at all? Yeah?
You see the football players jump in an ice bath?
Right.
Yeah.
Yeah, but they're also not really strength training in a competition. So if they're, in practice and they're weightlifting and stuff, then it wouldn't really make sense. But they basically just beat themselves to crap. Football players and stuff, that the ice bath is actually appropriate during that time. Good question, though. Any other questions?
The Finns, I've been in Finland a few times.
Mm-hmm.
They do the sauna thing.
Yep.
In all these apartments have the saunas in the basement, or they have their little house, they go in the sauna, and then they jump in the lake.
Yep. And so, again, remember how I talked about how cold exposure vasoconstricts your arteries? So it's strengthening your arteries because you're working those smooth muscles that most people don't use too often. Now, if you alternate between heat and cold, that's even more because you go into cold, you're constricting your arteries. Then you go into heat, which dilates your arteries. That's why, too, when you go into a sauna right after being in ice, it freaking hurts. Because when you have these constricted arteries opening up, it's like this weird type of pain that you can't really describe. It's kind of like this burning thing all over your body, but it's those arteries opening and closing. So it's actually a tremendous smooth muscle workout for your arteries and veins because you're training them to open and close, in a healthy manner. Because if you don't use it, you lose it. And so if we don't ever do this stuff, our blood just kind of stays in stasis and doesn't constrict or dilate.
Wouldn't I do that with the shower too? The hot and cold?
Yeah, you notice that, exactly. Yeah. You ever have ice cold hands and put it in heat and you're like, oh, that's kind of, right. Yeah, because your blood vessels are like, wait, you want me to constrict or open up? What is it? Yeah. Just personally, I'm doing the cold shower thing. And I'm almost up to my entire shower being cold. So I've worked my way up. And again, another challenge too when you're doing this is try to do deep breathing under that. Because we're trying to activate that non-shivering thermogenesis, that increase in metabolism in our fat tissue. So if we're just shivering the whole time, that's kind of defeating the purpose. And so eventually you stop that shivering mechanism and you're kind of able just to kind of relax. And that's why too, this guy like Wim Hof and stuff, they go in this cold stuff and it's like nothing. And they just get down in their swimsuit and they just jump in ice cold water and it's just like, yeah, what's wrong? And they sit there for 2 hours. It's insane. Yeah.